All right, in this very last example, we're going to find a formula for a rational function, and it's very much like that last example, except now instead of being explicitly told where the zeros are and the vertical asymptotes and the horizontal asymptotes, we have to get that from the graph. All right, so we have a graph, and so let's start with the zeros. Where are the zeros? It looks like we have a 0 here at -2, and we have a 0 here at 3, right? Because that's where it crosses the x-axis. So let's start with that. I'm going to start writing an equation, and I know that the function is 0 at those 2 points, so that means I have to have a factor of x plus 2, right? Because when I put in -2, it would be 0. And I would have to have a factor of x minus 3, right? In order to get the zeros that I want. All right. Now, the other thing I need to look at is the vertical asymptotes, right? It looks like I have a couple of vertical asymptotes at x equals -3 and x equals 1. So remember, the vertical asymptotes are where the denominator would be 0. So that's why I can't have, the function value can't be defined. The function value is not defined at those points x equals for x equal 3 and x equal 1, x equal -3 and positive 1. So I have to have an x plus 3 in the denominator and an x minus 1 in the denominator as well, because then I get those asymptotes. And I also have, let's see, what else do we need? So we also have a horizontal asymptote, right? So I'm going to look at what happens as x goes to infinity. Remember, the horizontal asymptote is determined by the long run behavior. So if I look at what happens as x gets larger and larger and larger and larger, I'm going to look at the leading coefficients. So as I have the function written now, the numerator would have an x squared and the denominator would have an x squared. All right, x squared over x squared is 1, right? Not 3. So I need a factor of 3 in there. And now that would go to 3, right? That would be 3. So I'm going to put a 3 in the numerator. Okay, and then I'll get the horizontal asymptote where I want it. So that takes care of everything except maybe the y-intercept. So let's check the y-intercept. Let's look at what happens when x is equal to 0. So when x equals 0, I want to make sure that I'm getting the right value, the right y-intercept. So if I put in x equals 0, I would end up with, as the function is written now, I would get, so put in 0, I would get 2, and then this becomes a -3. And then if I put in 0 in the denominator, I get 3, and then a -1. Okay, so I'm going to cancel those 3's. It looks like I get 6, which is what I wanted. It looks like it's going through 6. So yay, I don't have to do anything else. I'm done. And this would be my final answer. This is the rational function that would produce this graph. All right, that's all I have, and I'll see you in class.